Okay, so here we have a worded problem. A colony of bacteria which is initially of size 1500 increases at a rate proportional to its size, so that after t hours its population n satisfies the equation dn by dt is equal to kn. So what we've been told here is that initially the size is 1500. So when t is 0, n is 1500. Okay, that's what we've been told. We've been told some initial conditions. If the size of the colony increases to 3000 in 20 hours, solve the differential equation to find n in terms of t. Okay, so we've been told that when t is 20, n is 3000. Okay, so this should give us enough information to solve this to find a particular solution. So dn by dt is kn. So I'm going to use method of separation of variables. I'm going to divide both sides by n and then keep the k where it is and then multiply both sides by dt and then integrate both sides. Okay? So 1 over n dn will integrate to log n, and the right hand side will integrate to kt plus c. So we can see that there are these two unknowns. We don't know what k is, we don't know what c is, but we can then substitute in these this information here to find those values. So when t is 0 and n is 1500, we get log of 1500 is equal to k times 0 plus c. So c must be log of 1500. So that's the first thing. So we've got now log n is kt plus ln of 1500. Now, when t is 20, n is 3000. So 20, 3000. So ln of 3000 is equal to 20k plus log of 15,000. Now I can subtract the log 1500, sorry. I can subtract the log of 1500 from both sides. Now ln of 3000 take away ln of 1500 is ln of 3000 over 1500, and so that's ln of 2. So that means that ln of 2 is equal to 20k, and so k is equal to 1 over 20 of log 2. Okay, so that means that log n is equal to 1 over 20 log 2 t plus log of 1500. Now, in this question, they want us to get n in terms of t. So I want to e both sides. Okay. Now, 1 over 20 log 2 isn't a particularly nice value to work with, but there's not much I can do about it without turning it into a decimal. So I'm going to leave it as it is. But because we've got e of that plus log 1500, that's the same as e of this times e of log of 1500. The e and the log cancel, and so you can write that as 1500 e to the 1 over 20 log 2 t. Okay, and so that is what I'm looking for part A. Now, you could have got to this stage here and written this as log n, or sorry, n equals a e to the kt, and solved it that way. And that may well speed things up with some of the calculations. But you should get to the same answer. What is the size of the colony when t is 80? Well, that's quite straightforward. I just need to substitute t as 80 into this and figure out what I've got. So 1 over 20 times by log 2, and then times by 80. Now e to the power of that is 16 times by 1500, and that gets me 24,000. Okay, so that's the size of the colony when t is 80. How long did it take to the nearest minute for the population to increase from 2,000 to 3,000? Now we know that when it was 3,000, t was 20, so 20 hours. I need to work out what time it was when the population was 2,000. So 2,000 is equal to 1,500 e to the 1 over 20 log 2 t. So 2,000 divided by 1,500, 4/3. Okay, then you're going to want to log both sides. So we're going to get 1 over 20 log 2 t is equal to log of 4/3. Divide both sides by the 1 over 20 log 2, and we get, so ln of 4/3 divided by 1 over 20 times log 2, and that gets me t is equal to 8.3007 ... Okay, so that means that it was just past 8 hours when it hit 2,000, and then it hit 3,000 when we were at 20 hours. Okay, so in hours, the time was 20 take away that, and so that's 11.699 hours. Okay, but we want it to the nearest minute. Okay, so if I take 11 from that, that just leaves me the 0.699 bits of an hour. So we know that it was 11 hours, okay, and 0.699 hours, but I want to convert that into minutes, so I've got to times that by 60, and that gives me 41.955 minutes, which is 42 minutes to the nearest minute. Okay? And that's how we can solve a problem like this.